In this cell, I've split our features and encoded labels into training, test, and validation sets. I started by splitting our features and label data according to their split frac. So I'm reserving 80% of my data for training, and I'm basically getting the index at which I should split my features and label data based on this value 0.8. And actually, I could have just put in this variable here. Then I'm splitting my features first, getting the features up until my 80% split index. This makes up my training features, train X. Then I'm getting the remaining data, so after the split index. And that makes up my remaining X. Then I'm doing the exact same thing, but for my labels data, splitting it at the 80% index to get my training labels and my remaining data. Then I'm doing something similar all over again, only with the remaining data. I'm getting an index to split this data in half, so at the 0.5 mark. Then each half of our remaining X will make up our validation and test sets of features, and each half of remaining Y will make up our validation and test set of labels. And that's it. The last step I'm doing is checking my work and printing out the shapes of my features data. I can see that I have the largest number of reviews in my training set with a sequence length of 200, and my validation and test sets are of the same size. If you want, you can do the same thing for your labels data, and you should see the same number of rows here. So this is 80% of my data, 10%, and 10%. After creating training, test, and validation data, we want to batch this data so that we can train on batches at a time. Typically, you've seen this done with a generator function, which we could definitely do here, but I want to show you a really nice way to batch our datasets when we've split up our input features and labels like this. We can actually create data loaders for our data by following a couple of steps. First, we can use PyTorch's TensorDataset to wrap tensor data into a known format. And I can look at the documentation for this here. This dataset basically takes in any amount of tensors with the same first dimension, so the same number of rows. And in our case, this is our input features and label tensors. And it creates a dataset that can be processed and batched by PyTorch's data loader class. So once we create our data, wrapping it in a tensor dataset, we can then pass that to a data loader as usual. Data loader just takes in some data and a batch size. And it returns a data loader that batches our data as we typically might. This is a great alternative to creating a generator function for batching our data into full batches. The data loader class is going to take care of a lot of behind the scenes work for us. And here's what this looks like in code. First, I'm creating my tensor datasets. To create my training data, I'm passing in the tensor version of my train X and train Y that I created above. And torch.from NumPy just takes in NumPy arrays and converts them into tensors. So I'm doing that for my training, validation, and test data. And if you named your data differently above, you'll have to change those names here. In fact, I could have actually done these steps the other way around, creating a tensor dataset for all my data, and then splitting the data into different sets. Both approaches work. Then for each tensor dataset that I just created, I'm passing it into PyTorch's data loader, where I can specify a batch size parameter, equal to 50 in this case. So without the messiness of loops and yield commands, this defines training, validation, and test data loaders that I can use in my training loop to batch my data into the size I want. So this gives me 3 different iterators, and I just want to show you what a sample of data from this data loader looks like. I'm looking at our train loader and getting an iterator, then grabbing one batch of data using a call to next. So this should return some sample input features and some sample labels. Then I'm printing out the size of my input, which I can see is the batch size 50 and the sequence length 200. And the output label size, which is just 50, one label for each review in the input batch. And I see my tokens and the encoded labels as well. So this is looking really great. And next, we can proceed with defining and training a model on this data.